All around me are familiar faces, worn out places, worn out faces, bright and early for the daily races, going nowhere, going nowhere. Their tears are filling up their glasses, no expression, no expression. Hide my head, I wanna drown my sorrow. No tomorrow, no tomorrow.
This chart shows that women are more likely to be able to refuse sex and negotiate condom use the better off they are socioeconomically. However, the same study found that the more autonomy the women were given in their daily lives by their husbands, the less they used these abilities to negotiate safer sex, almost as a sort of payment for their husband's leniency. Despite that alarming trend, there is still some hope, as other studies have found that female sexual and HIV risk behavior has been decreasing throughout the years. While that is a promising trend that the researchers discovered, unfortunately, the most recent data is only from 2005, almost 10 years ago, and HIV and sexual risk behaviors of women may have changed significantly since that time. Meanwhile, numerous studies have documented, as recently as 2010, that men continue in their traditional habits of frequenting prostitutes and other forms of high sexual risk behaviors. These continuing trends put men at increased risk of contracting HIV. While it may seem likely that it is men that have the increased risk for contracting HIV, and thus more incident cases, it is actually not true. The recent studies have discovered that out of both of the two groups, housewives have the higher rate of incident cases. Could this be because their husbands are all already infected and therefore do not count as incident cases? Or are there other factors at play? New evidence is needed to explore this situation further and to determine if the recent trends in incident cases are due to high prevalence rates among men already, or if incident cases are in fact due to other factors such as increased female sexual risk behaviors that previously have gone unnoticed. That is where this study comes in, as it attempts to identify, when taken as married couples all HIV negative, which individuals, male or female, are more likely to have incident cases of HIV infection. In addition, this study seeks to understand HIV risk behaviors between the two groups and to see if the continued trends of male risky behavior as compared to female behavior are continuing. So now that the background on this study design is all set up, let us delve into the specifics of what exactly the study is attempting to answer. So for the study, there are two different hypotheses that we are looking at. The primary hypothesis is regarding incidence and gender. The null hypothesis is that HIV incidence rate of married individuals is not associated with gender. The corresponding alternative hypothesis is that HIV incidence rate of married individuals is higher among husbands than wives. This is supported in the background research, as historically men are more likely to engage specifically in high sexual risk activities. The secondary hypothesis for this experiment is to take the primary hypothesis one step further and attempt to analyze perhaps why these differences in the incidence rates are being observed. So in order to do this, the null hypothesis is that HIV risk behaviors of married individuals are equivalent between genders. The alternative hypothesis is that HIV risk behaviors of married individuals are more prevalent among husbands than wives, for the reasons previously stated. To test these hypotheses, a prospective cohort design was the best available option. By utilizing this design, you are able to test incidence and relative risk across a time spectrum. Additionally, controlling for HIV negative tests at the beginning of the study will make for a much better experimental design because it will allow us to see, potentially, which spouse first contracts HIV within the marriage. Knowing which spouse first contracts HIV is critical to the hypotheses. Because of this, once one individual in an enrolled couple becomes infected, both the members of that couple are removed from the study. This is done because, according to the literature, it is a near inevitability in Cambodia that if one partner becomes HIV positive, that within a marriage, the other partner will also become HIV positive. For this reason, we are only interested in discovering who first becomes HIV positive and thus brings HIV into the marriage. For this study design, then what type of study sample is necessary? Well, the inclusion criteria to be used in this study is that the participants must be married, both individuals must enroll from the couple, they must both be HIV negative, have a permanent home, must not be planning on moving or divorcing within the next 5 years, and be between the ages of 16 and 50. We hope that by satisfying all of these inclusion criteria, we will have a diverse sample that does not drop out disproportionately from the study. How then will we go about choosing who participates in this sample? To do this, we have decided to use a multi-stage sampling technique. Multi-stage technique is most appropriate for this matter because it most closely approximates a random sample across the entire country. To do this type of sampling procedure, we are first going to select all of the cities within Cambodia that have greater than 50,000 people as their population. These urban centers represent the majority of the developed areas in the country and are where we're most likely going to find the highest incidence of HIV and also the most places where people have a permanent home and thus are able to be included in the study. From this list of potential cities, we are going to randomly select 5 urban centers. Within these 5 urban centers, we're going to select 5 health centers or hospitals from each of them. In so doing, these 2 random processes, we hope to get a wide selection of the people across the country and represent all of the diversity. Once the health institutions are selected, we are going to screen for HIV negative couples that are patrons to these locations. In Cambodia, the federal government provides free HIV testing for everyone, so long as they sign a waiver allowing that information to be used for research purposes. In so doing, we are allowed access to the HIV test results and can use this information to first screen for individuals. By using this pre-screening method, we are hoping to eliminate the number of people that will come into our study hoping to be a part of it and then finding out that they are HIV positive after a test. That being said, we are not going to use their current medical records as a guarantee that they are HIV negative. To make sure that they are not before they are enrolled in the study, we are going to give them another HIV test at the time of enrollment to concretely confirm that they are HIV negative. In all, we hope to enroll 100 different individuals from each of the health centers, which would correspond to 50 men and 50 women that are all married. In selecting 100 individuals from each of the different health institutions, we will have a total sample size of 2,500. Quite a large sample that will help to balance out the relatively low prevalence rate of 2% of HIV in the population. Using this study sample, there are 3 main measures that we are interested in. The main exposure variable in the study is the gender of the married individuals recruited. The main outcome variable, then, is the incidence rate of HIV for those different genders. In order to test this outcome variable, we are going to be using HIV blood tests given every 6 months over a 5-year period. As stated before, Once one member of the marriage becomes an HIV positive, both the members are removed from the study as having the disease event. In the case that both members test positive at one of the 6-month cycles, they will be added to each of their respective categories. By including them in the study as opposed to removing them altogether for inconclusive results, you are raising the sample size of the number of individuals that test positive, and in so doing, you are making the differences between them seem less severe. This will help make the results, if they prove to be statistically significant, that much more potent because the sample size presented represents the largest possible sample size of individuals that test positive from the cohort. While HIV status and gender are relatively straightforward to measure, the secondary hypothesis requires also quantifying the risk behaviors of the participants of the study. To do this, we are going to give the study participants a survey that asks questions about their sexual risk, their drug use past, perhaps other medical conditions, all things that relate to HIV risk behaviors. The results of this survey are going to be quantified on a continuous scale based on a score assigned to their survey results for how many answers they gave that are quantified as risky. This survey will be given for all individuals immediately after enrollment. This is so that if dropout occurs, we are also able to analyze these behavior results to see if there was differential dropout based on any of the different observed behaviors. After collecting all the data, we're going to calculate incidence rate. Incidence rate is going to be calculated as a person-time calculation for all of the person years that the participants spend in the study while still at risk for HIV. Then, using these incidence rates, we're going to perform a t-test to compare the means of the incident rates for the men and for the women. By doing this type of a test, we are being able to see if there are concrete differences statistically between the genders in terms of how frequently they contract HIV and bring it into their marriage. For comparing the differences in HIV risk behaviors between the two genders, a multiple regression analysis is going to be used. That's going to compare all of the subgroups within the HIV risk behavior survey. These groups, as separate from the total composite score, give a composite score for each of the individual sections, such as sexual risk behavior, intravenous drug use, etc. By looking at these subgroups individually, we will be able to see if different genders perhaps are more risky in one area of their life than the other, or if one gender is just risky across the board. For all hypothesis testing, an alpha level of 0.05 is going to be used, such that if the p-value of the corresponding test is less than 0.05, then it can be concluded that the null hypothesis should be rejected in favor of our alternative hypotheses. Additionally, through doing these hypothesis tests, we are also going to be calculating risk ratios, relative risks, and odd ratios in order to determine exactly how much more at risk one gender is as opposed to the other gender for representing different behavioral characteristics or also for having a higher incidence rate. While this study design seems to have very many broad implications that the results can provide, there are also very many limitations to the study, as with any other study. Some of the major error potential that we are trying to compensate for is due to such things as interviewer bias. Interviewer bias could occur in our study design if an individual is illiterate and needs to have the survey read to them. An interviewer that's not properly trained may provide certain emphasis on one answer over the other. Even if unintentionally, this could cause the participant to answer in a particular manner that they think the interviewer wants to hear. This is particularly true because the survey delves into behavioral topics that can be highly stigmatized, and an individual may already feel pressured not to answer correctly if they feel ashamed because of how they act. Recall bias could also occur in the survey process because we were asking participants to remember for a period of months back into their life how exactly they performed with very specific questions in terms of sex and drug use. For many individuals, they may not physically be able to remember exactly what they did, and so their numbers could be skewed because they gave inappropriate estimations of their behavior. Error that could occur in the primary hypothesis results is primarily due to testing and clerical errors. As with any test, an HIV test is not 100% accurate, and because of this, there may be false negatives and false positives included within our results. While we don't expect there to be many of these numbers, they could be significant. However, because the test provides these at a random assortment, we hope that the error from the test, or perhaps from random clerical errors of the researchers, are balanced evenly across the entire study and therefore will not provide any bias effect. Overall, we hope this study design provides a highly generalizable study of what exactly is going on in terms of HIV and married couples. We know that this study will be applicable to other urban centers, Cambodia, but there is some concern that that will not be accurate to rural areas, as we did not include these in the study. The reason for not including rural areas is because we're concerned about differential loss to follow-up, which would be higher in rural areas because the people are more migrant populations, they're typically poorer and may not be able to give as much time to the research as necessary, and also the populations are just simply harder to reach by the researchers as the road and transportation system in Cambodia is not very well developed. By sticking only to these urban centers, we can then combat these problems and reduce the loss to follow-up that would have been observed in the rural areas. Therefore, we hope to keep the loss to follow-up below 20%, which would lend generalizability and credibility to our entire study. In the end, we feel this study is the best designed study to combat a growing HIV epidemic in Cambodia.